Hello everyone, I'm Bob Ward from Microsoft, here with another special edition of Azure SQL for Beginners on Performance, a guide to performance troubleshooting for Azure SQL. In today's episode, we're going to focus on another scenario for performance troubleshooting dealing with high CPU on something called an anti-pattern query. Now, if you remember, in the other episode, in the introduction in the last episode, we talked about this running versus waiting concept. So today in this episode, again, we're going to focus on the running scenario of high CPU, and we're going to look at queries that affect and show why we're having a high CPU problem. Now, I use the term anti-pattern query, and that's going to be the focus of today's scenario. But you're trying to ask yourself, what is an anti-pattern query, Bob? Well, this is my definition. It's a query that's designed in such a way that you don't get the performance you expect, but it's based on how the query is actually written and how the different results come back from the query. Let me show you an example. Let's say I have a table called customers. You saw that in our last episode. And I build an index on customer ID. Notice in this particular case that the customer ID is a type of nvarchar. Let's say I create a stored procedure to go select data from this table by customer ID, and I use a parameter that I'm going to equate to the customer ID column. This parameter is defined as an integer. But remember, our customer ID in the table is an nvarchar. Now, SQL Server can convert the int to an nvarchar to get you the right results, but here's the problem. It's called an implicit conversion, and when that happens, it's a classic anti-pattern query where if there's an index that we've defined here, we're not allowed to use the index. So it's a scenario that's going to surprise you. You're going to have an index built, and you don't know why it's used, and it could be one of these scenarios. So what's the troubleshooting process for this? Very similar to as we've done in the last episode. We're going to see it's a high CPU problem. We're going to identify those top resource-consuming queries. We're going to look at the query plan, but look at this time. There's an index that exists, but it's not used. So we're going to see, is there an anti-pattern query involved? And in fact, in some cases, SQL Server can warn you that that might be the case. What we'll do is we'll go fix the query to adjust the problem and make sure we solve the anti-pattern issue, and then check to see if performance has improved. That's the process. So remember, as you see this demonstration I'm going to show you now, you can use Azure SQL Workshop to go try this for yourself with your Azure SQL subscription. So let's see it in action. It starts with a database in Azure SQL that I have here. Like I've done before, I've got a customers table that I've built with an Azure SQL database. I've got some of the same columns for identifiers and IDs. Notice the ID here for nvarchar. Now in this particular case, I've gone ahead and built indexes ahead of time because I want to make sure that these indexes are used properly if I need them. In addition, as you see down here below, I've got two stored procedures to go get customer data, one by the tab key and one by the customer ID. So I think I'm kind of set up for success to get great performance. But as we showed before, let's go into the Azure portal to see if we've got a slow problem. Let's say there is a slow performance problem, and I use that technique of running versus waiting. I'll go into the monitoring tab. I'll look at compute utilization. You can see here another situation where you have sustained compute utilization at 100%. So this is identifying one of those running problems, high CPU, and using our troubleshooting process, we need to try to identify what are the top resource-consuming queries. So back over to the query store, just like we did in the missing index scenario, we're going to use this top resource-consuming query report and identify what is that query. Now, I've already pivoted on average CPU time, and if you look over and hover to the right, you can see it's almost like a second of average CPU time for execution of this query. That's a lot for executing this query. Now, notice here at the bottom, the plan. Here's the query that we're trying to run, but it's using a table scan, and we knew we built an index originally, but it's not using that index. So we got to go figure out why. Now, if you look down here below, you can see I can verify that I have the index. I can see that I have a customer ID index that matches built on the customer ID column. So I would expect SQL Server to be able to use this index, but I don't know why just by looking at this. Notice this warning field, this warning icon on top of the select statement. This gives us a warning that there's an implicit conversion going on in this query between an integer value passed in and the value of our column. This is a warning of a potential anti-pattern query. So let's look further at the problem. Look at and back again at the stored procedure definition we had as opposed to the column definition. We know I have an nvarchar 10 column for customer ID But in our customer ID, our get customer by ID stored procedure, we're passing in a parameter of an integer. So you can see this conversion problem exists by definition on how we wrote the stored procedure. So how do we solve this? Well, what I love about SQL Server is I don't have to drop the procedure. I can run the create or alter syntax to just simply change it and use the proper data type. So I can take my customer ID and set it's an nvarchar10 column now. And now when I run this and execute the procedure, I can go see whether performance hasn't improved because of it. Remember O-stress we used in the last scenario for missing index? This was the workload execution with the anti-pattern problem, about 12 minutes. Now if I run it again, less than a minute, look at that, less than a second to run that entire workload with the proper anti-pattern query resolved. But I want to go make sure that I can identify that my index actually got used here properly. So go back over to the query store reports. Now you can see here, you see the table scan listed. You're like, what's going on here, Bob? Well, the performance was so fast for that execution that the chart is so small to the right, I have to hover over it to see it. So if I click on it, you can see this is the one for the index seek for that same query I'm running. It's a new plan as opposed to our scan. I can look at the average CPU. Boy, I love this. Here's first of all, the average duration is less than a millisecond. And you will see as well that the average CPU as well is that fast. So with this in mind, let's do this. I want to make sure that I can execute this again consistently and a lot of times with this new thing in place, this new anti-pattern query resolve with a new index. So what I'll do is I'll look at query store reports after running the workload a bunch of times to make sure that that average CPU is still fast. So hovering over, I can see here, look at that again. Execution count around like 500,000 rows, that average duration less than a millisecond. Back over to the portal, when we flip over there, you can see, look at that. There was a sustained CPU problem we had before. Now you can see the new performance with 500,000 executions is well below what we had before. So great CPU utilization here for our query, efficient use because we've changed to avoid that anti-pattern problem and use an index that we had built to make sure our query runs performant. So there are other examples of anti-pattern queries. We've got a website here you can go take a look at to see what those examples look like. You can see in the list other scenarios that could cause one of these problems where an index may not be used. You see one of them, as we showed here, you can get a warning in a query plan, but we also have an extended event that you can use to look at some other examples. So anti-pattern query examples or problems can be sometimes difficult to detect and resolve, but we've given you some guidance on how to go do that. The key signature is that you've got an index you've built, but SQL Server can't use it. So in summary, we've seen a problem that is running or waiting. We determined that's running. We determined what queries were involved. We looked at the top resource consuming query to go figure that out. We looked at a query plan to see if an index is missing, which it's not. The index exists, it's just not used. And in this particular case, it's because we had an anti-pattern query that we had to resolve because of an implicit conversion problem. So we want to make sure you have more resources as you look at problems like this. And at the top, you can see here is a site you can go look at and learn more about anti-pattern queries. Here are other resources, as we've shown you in this series, for videos, the actual scripts to go see this, a learning path from Microsoft, and other resources to learn more about Azure SQL, including books to dive deeper into the topic. We hope you've enjoyed this episode. To look more at a high CPU problem to an anti-pattern query. Look forward to seeing you next time on a special edition of Azure SQL for Beginners on Performance.